Hello students. So today we will be starting a new chapter, chapter number 6, called Combustion and Flame. As the heading suggests, this chapter is in two parts. One is combustion, other is flame. I will just in a minute or two tell you the content. First we will learning about combustion, means what is combustion, what are types of combustion, everything related to combustion. Then which are combustible substances and which are non-combustible substances. This is, you can say, topic 1. Then after understanding what is combustion, we can define what is fire and how to control that fire, how to extinguish the fire. After completing this topic, we will go to the next part called flame and its type. So for it, we will be doing it a very introductory part about the candle flame. What is candle flame, what is its structure, and then we will study about fuel. And in fuel also we will be studying what is an ideal fuel, what are the drawbacks or problems we are facing with the current scenario of the fuels that we are using, so how we can find the solution of these problems. So that will complete this chapter. So as it is a small chapter without any numerical, I will complete it in one session only. So now we will start with combustion. Now combustion is a chemical process, means chemical reaction. You know what is a chemical reaction. Chemical reaction means we will be taking two or more reactants, and under suitable conditions they will react with one another and form products which would be chemically different from the reactants. Is it all right? So that is a chemical reaction in general. So combustion is also a chemical reaction in which a substance is reacting with oxygen. So one reactant is oxygen, and instead of oxygen normally we use air, because air contains 20% oxygen. So oxygen will react with that substance. But in case you are interested in to obtain very high temperature, then instead of air you can use oxygen also. Okay. So now when they react, good amount of heat is liberated. This is very important. Then only we will say it is a combustion reaction, when sufficient amount of heat is liberated. When heat is liberated, many times the combustible substance, temperature rises to such an extent that it not only glows but gives light. So means the combustion has taken place with a flame which is giving light. And in certain cases we will not see the flame but we will see the glow. We will see that substance is glowing, like your filament bulb. When heated, it glows and gives light. So this is the definition of combustion. So like you have seen various things, candle burning is a combustion, camphor is a combustion, both are giving flame also. Coal will glow. Coal normally glows. If you heat the wood, it also glows. Normally it glows, but in case you heat it for a very long time and the wood is dry, it may give small amount of flame also. Like in case of fire, furniture also burns. It gives fire. Okay, but in the beginning for a long time it will glow. Wood, especially wet wood, which villagers used to take from forest and use in the kitchen. Okay. Then related to this combustion, there is a term called explosion. Now, what is explosion? It is also a combustion, but during this combustion a good amount of gases have got formed and it does not find any much space to get emitted. So it tears off the container and gets emitted out, and in this process the pressure waves get generated and good amount of loud sound is heard. So that is called explosion. So explosion means the energy liberated during chemical reaction not only gets converted to heat and light but also to sound and pressure waves. You know its example, crackers. You have busted various crackers and heard the sound. Okay. Now we'll try to understand what are combustible substance and what are non-combustible substance. It's very easy. The substances that undergoes combustion like paper, cloth, coal, magnesium wire, all those things, they are combustible because if you heat them in air, they will burn. They will liberate heat. So such substances we are also calling fuel if it has got other properties of fuel, like coal, petrol, wood. They are fuel, and because they undergo combustion and liberate adequate amount of heat, which can be utilized. Now this fuel can be solid, liquid, or gaseous. We will be learning this in next slide or in some later on. Then non-combustible substances which do not burn, like stone, iron nails or gold ring, glass, etc. So they are called non-combustible substances. Now let us try to understand, this is very, very important, not from the examination point of view, but also from understanding the chapter later. Conditions for combustion. When does combustion will take place? So these three conditions have to be fulfilled. First, you should have a combustible substance like coal, petrol, kerosene, wooden furniture, etc. There should be some combustible substance. Then there should be adequate supply of oxygen or air. Then temperature of this combustible substance should be more than its ignition temperature. I will explain to you what is ignition temperature. You know that coal or wood, if you just ignite with a matchstick, it may not burn immediately. You have to heat it to some temperature for some time, then it will burn. Even the kerosene stove does not burn instantaneously. Kerosene has to first get heated up. The gas also you have to give some spark, electric spark or with a matchstick, but then it will burn quite early. It will not take much time. So means ignition temperature of the gas LPG, which we call it, is low. So ignition temperature means minimum temperature at which a substance will catch fire. So the lowest temperature at which a substance catches fire is the ignition temperature. So the ignition temperature of combustible substance should not be very high. Otherwise, you will have to do good amount of heating in the beginning. At the same time, it should not be low, that if you have stored it in the godown, it may catch fire due to room temperature. So it has to be in a safe region, much more than room temperature and not very high. Like petrol, diesel, their ignition temperature is low. So in case they get heated up, they may catch fire. Okay, so this is about combustion. Now we will learn types of combustion. Now combustion types, first category is rapid. Rapid means the combustible substance will burn in a very short period of time when you ignite it. As soon as you ignite it, it will start burning within very short period of time. For example, you have got an experience of igniting the gas, Bunsen flame. Okay, Benson burners who have no gas burner. So to give a matchstick or to hit it in less than a 30 seconds or around 30 seconds, it will start burning. So that is considered as a rapid. Okay, but for certain things it may take much more time. So this is called rapid burning. Then spontaneous. Now I explained to you what is ignition temperature. So if ignition temperature is around room temperature, then at any time when room temperature becomes more than ignition temperature, that substance may burn. Combustion will start in that substance. Good example is yellow phosphorus. If yellow phosphorus is kept in room temperature, it may catch fire by itself. So that is called spontaneous burning, spontaneous combustion. So spontaneous combustion example is phosphorus. Then another example is in forest or in fields when the grass becomes yellow due to drying up. So this dry grass sometimes catches spontaneously fire due to sun's heat, solar heat. So we might have heard in TV that in certain places there are forest fires are taking place. So that it is called forest fire, because once the grass starts burning, the heat will spread to trees, short trees to tall trees, and then the trees will start burning. They may not burn immediately, but when they get heated up to the temperature more than its ignition temperature, will start burning. Then sometimes accidents take place in coal mines, because in coal mines we have coal dust. So coal dust ignition temperature is not very high. So sometimes we get fire in coal mines due to spontaneous burning, spontaneous combustion of coal dust. So these are two. Then third is explosion. In explosion, as I told you, that besides heat and light, also sound energy gets produced. Okay, so that is called explosion, like the crackers. Then we say complete combustion and incomplete combustion. This is very important. Now complete, as the word says, complete combustion means the fuel has got fully converted to carbon dioxide and water. Means oxygen has fully reacted with the hydrocarbon and produced carbon dioxide and water and adequate amount of heat. So heat produced will also be more. And the flame for complete combustion is blue. Now incomplete combustion, oxidation of fuel has not completed. Like oxygen reacted with carbon but has so far formed carbon monoxide. Now if they would have been more oxygen, carbon monoxide would have got converted to carbon dioxide. So it is an incomplete oxidation or incomplete reaction. So we say incomplete combustion. So the byproducts for this incomplete combustion would be carbon dioxide and water, but also carbon monoxide, and sometimes some carbon soot is also left, means it has not got oxygen to get converted to carbon monoxide and carbon dioxide. So in incomplete combustion, the byproducts are carbon monoxide and carbon also. So we will see in detail the differences between these two in the next slide. Now what we call burning. When a flame is created during combustion, we call it burning. If flame is not created, we will not call it as a burning, we will refer to as only combustion. Then another word is smouldering. Smouldering means during combustion, you might be seeing yellow flame like candle, coal. You are seeing yellow flame. That yellow flame is due to carbon particles have got heated up to such a temperature that they are glowing and emitting yellow color light. So the yellow color light is coming. In case no flame comes from the solid fuel like coal, peat, wood, their temperature has increased, combustion is taking place, so they are glowing, and small amount of smoke is coming, but there is no flame. So when there is no flame and combustion is taking place, we call it smouldering. We don't call it burning. For burning, flame should be seen. You should be able to see the flame. Is this distinguish clear? So then we'll go to next slide and try to see the difference between complete combustion and incomplete combustion, which we had seen. Now let us slightly try to put in the form so that it will be easy for you to answer in exam. Oxidation of fuel is complete, here it is incomplete. Energy released, here is more, here it is less. Amount of oxygen, here it is more high and here it is low, because that is why it has got incomplete. Products are carbon dioxide and water. Here in addition to this, we also have carbon and carbon monoxide. Here the flame is blue in color, here the flame is yellow in color. So looking at the flame color, you can come to the conclusion that whether the combustion is taking place is complete or incomplete. Then effect on environment. So now here when carbon dioxide and water is coming, we know that carbon dioxide is a greenhouse gas, so it will cause this greenhouse gas effect means our climate change, temperature increase of earth will take place very, very gradually. Okay, because it restricts the heat which is getting reflected from the earth. Okay, now this complete combustion example is Bunsen burner, whereas incomplete combustion, in addition to this, carbon monoxide gas is also getting involved, which is poisonous. This is to be noted. Poisonous means when we inhale this gas, then it combines with red blood corpuscles of our blood and gets absorbed. Once this gas gets absorbed in RBC, it will not get removed. That RBC has become useless in our body. So if we inhale large amount of this carbon monoxide, then a good amount of our RBC will not function and a person can die also. So you should never burn wood, coal in a closed room, because in a closed room gases cannot go out. So carbon monoxide percent will go on increasing. So this point you should note. Few incidents have taken place where persons have died during winter due to burning of wood in their house with doors, windows closed. Okay, so now we'll go to next slide. As I told you that we should remember conditions for combustion for understanding the other part of the chapter. Like first condition was that we should have a combustible substance. So in case you find there is a fire in some building or in some factory and you are alone, or then what you will do? So first you try to, without taking risk of yourself, wherever there is a fire, suppose the fire is in this area, here is the fire, then in the surrounding areas, from surrounding areas, you remove all combustible substances, because due to this fire they are also getting heated up and they may also catch fire after some time. So if we remove all combustible substances from here, then the fire from this zone will not spread outside. And by that time you might have definitely called your fire brigade and they will take action how to extinguish the fire. Is it all right? So what we learned, there should be a combustible substance. So if there is no combustible substance, fire will not prolong. Then another example, we have learned that oxygen is required. So that is why, in case suppose a person is working in the kitchen, clothes have caught fire, then we should give him a blanket to wrap around his body so that oxygen supply is cut off. Then the clothes which were on fire will get extinguished. So we are cutting off the oxygen. You can do this experiment. You burn a candle. And then cover it with any jar. You will see that it will get extinguished because it will stop getting oxygen supply. So, and third principle we learnt was that we should have more than ignition temperature. So here also, when we are removing the combustible substances, or whenever there is a fire brigade will not only extinguish this fire, but all around it will put water so as to lower down the temperature, so that there should not be a spontaneous fire after some time if the temperature is more. We will be learning now how these three principles are used in fire extinguishers, like paper, wood, coal, plastic, forest fire, dry grass. Now this have taken place. So water extinguisher we can use water. What water will do? Water will bring down the earth temperature, and so they will get extinguished. But you should not use water in case of electrical fire, like your meter room, where there are many electric meters are there, or any place, transformers, where the electrical equipments are there, because you know that water is because normally water means not distilled water but tap water. So tap water, due to dissolved salts, is a good conductor of electricity. So if electricity may pass through water and may give a shock to the person who is holding that hose of water, and he may get a shock, electric shock. So water is never used for electrical fires. Then it is not used for flammable liquids. Like flammable liquids mean like petrol, diesel, all this, and flammable gases, CNG. So this should not be, because density of this is flammable liquid is less than water. So in case you add water, in case we add this, suppose this is the thing where there is a fire, liquids are there. So when you are adding water, water has got more density, so will be at the below, and oil will be at the top. So petrol, diesel, whatever oil has caught fire, so its fire will continue. Water will go and settle at the bottom because density is more. So now, then the question arises, then what to do for that? That answer is given below. In case of electrical fire, then we can use carbon dioxide. Carbon dioxide is in cylinders. You have to push it and then rotate it. The two chemicals which are there will chemically react and carbon dioxide gas will come out. But this should not be used for outdoors, because there will good diffusion will take place, and in case of large fire outside, you cannot use that. So otherwise, for all these things, carbon dioxide is used. Now, in case of this as well as this, the best extinguisher is foam. But foam cannot be used for electrical equipments. Foam cannot be used for electrical because it is having some water. Then flammable and combustible liquids, flammable gases and electrical, you should use dry chemical powder. That is why in case when fires take place outside in electrical or in certain flammable liquids, people just throw sand in it. So throwing sand on it What it is doing? It is cutting off the oxygen supply. Is it all right? So now then we'll go to next topic about flame. So now we'll go to part 2 of the chapter. I will explain to you about flame. Flame is visible gaseous part of fire. Whenever a combustible substance has been ignited, it has reached a temperature to such an extent that we can see a flame on it. So we say flame means it is visible gaseous part. This condition has come because of exothermic chemical reaction between combustible substance and oxygen. Okay, this to know as such by what is flame. This is how we can define it scientifically. Now, in case the flame temperatures, the air temperature, where there is a flame, as I suppose this is the flame. This is the flame. So means now here at this region we will be learning at the very high temperature. So the air surrounding this will come to a very high temperature. If the temperature of this surrounding air becomes to such an high value that they turn into ions, means nitrogen, oxygen will form ions. Some electron will get emitted from them, so there will be negative electron and positive ions. So if ions gets formed, then that area or that location is said to be, it is plasma. We will be learning this in detail in 12th standard or later on. So that is plasma. So when my gaseous state is having many ions. Okay, in short, that is you can learn. Now I will this is a very simple sketch. This is the candle I have shown. This is the wick of the candle. I have shown it in very expanded view so that you can have a look. So this is the wick which I have shown is a black color. So this is called black zone. This is at minimum temperature. Outside there is a yellow flame, and this also I have expanded it to a very large extent. Otherwise this is in very small thickness. So this is a blue flame. So outside we have a blue flame. Here the temperature is maximum. So here, in case the air has in the ionic state, so we say plasma has got formed. Now this is called non-luminous, because this is not giving light. Light is being emitted by this yellow color. So yellow, as such it is yellow, and gradually it is becoming orange and pink. So the color changes based upon what is burning and what is the temperature. So importantly there are 4 zones. Outside is at a very high temperature, and that is non-luminous. Below it is yellow in color, that is luminous, so that is at a moderate temperature, and below it is the black zone, which is at the least temperature, and it is slightly hot. And exactly where the wick ends, here the wick is ending, exactly at that point, you can say very near to that point is the dead zone, means there is nothing. It is just like a slightly more than room temperature. Well, little amount of heat will come here. So is it all right? So these are the 4 zones of wax. This to keep in mind when I am explaining you this slide. So now we'll again come back to this. So color and temperature of the flame. So they are dependent on the type of fuel used. Okay. Then now let us try to see how this thing happens. Suppose we are taking a candle. we are igniting it with a matchstick, then the fuel wax first will get vaporized due to heat, and once wax gets vaporized due to heat and its temperature is more than the ignition temperature, then it will react with the oxygen in the air and exothermic reaction will take place, more heat will get liberated and it will further vaporize the wax, and this process now will continue and always the wax is getting melted and it is going to a high temperature. Now as the temperature increases, so we will see that glow, because glow is due to carbon particles, because when wax is getting vaporized, it decomposes and some carbon particles are also formed. These carbon particles are reaching very high temperature due to exothermic reaction and they glow, and that glow is nothing but yellow color light that we see. So yellow color light is there, but gradually as we proceed upward or as the flame proceeds further, combustion is coming towards the complete state, and at the extreme end, which we call it outer zone, it is blue in color because there now the combustion is complete. So this is how we come to this flame of the candle. The flame temperature of the flame causes that vaporized molecules to decompose. This I have explained to you, and it will form various incomplete combustion products. Carbon monoxide will get formed, carbon will get formed, and they will get heated up. And as they proceed further, they will get further oxidized, and at the outer zone, my combustion is complete. So this is how the thing proceeds. Okay. Now we can verify this with a better spoon. I will explain you what you see. Now you see here, as I told you, we have got melted wax. Only wax has got melted, and now only this yellow color means combustion is reaction has taken place and carbon particles have formed. Wax has got decomposed, carbon particles, incomplete combustion has taken place. So if we take a spoon or a hollow rod, I would say, to take a long hollow rod. This is my hollow rod. Okay. So take this long hollow rod and place it. First let us try to place it here. So here I have got melted wax. So if I place my rod here, then and you place it such that this is at the lower end, so the melted wax may flow through this pipe and will come out here. So if I take a matchstick and ignite it here, I can see the flame of similar to this, though it might be smaller in dimensions. Okay, so this shows that here I was having melted wax. If I put my spoon here, I will see that this has become black. When I remove it, if I see here, I will see it has become black. So means this area is having carbon particles, and if I place it here in this blue color, I will see that it has only good amount of heat is getting transferred to the other end. It is becoming very hot. So with this, in this manner, experiment can be done, but it has to be done by taking good amount of precautions. Okay, so the reaction is proceeding here. Here candle get at this point, you can say my candle wax has got melted. Now melted wax is getting decomposed. Now chemical reactions further are taking place. Incomplete combustion is taking place here. So carbon is becoming red hot and it is giving yellow color light, and here my combustion process is over at the end of the blue flame. Is it all right? Whatever I have explained, I have written here. Outermost zone means blue zone. This zone forms the covering. Wheel means covering of the candle flame. It is at the extreme end. Due to complete combustion, it is the hottest and it is blue in color. So remember, outermost zone is hottest and is blue in color. It is non-luminous because there are no solid particles which are glowing. In the middle zone is the yellow color flame that you see, and here because carbon particles have become hot, they are glowing. So it is moderately hot area. Innermost zone, this is the least hot part, and as soon as the wick is ending, there is no burning has taken place. So these are the 4 zones. Now let us come to fuels. Fuels are combustible substances that liberate good amount of energy so that they can be used as fuel. Now, what are the characteristics of ideal fuel, or theoretically how we want that fuel should be? So that is called characteristics of ideal fuel. That how the fuel should behave, like characteristics of a good student. He should come to school daily, do his homework daily. So in the same manner, characteristics of ideal fuel. It should be readily available. It should be cheap. It should be easy to transport and store. No incident or accident should take place during transportation and store. It should burn easily in air at a moderate rate. It should be easy to control. Means like why we are not using kerosene stove and we are using LPG gas cylinder. The main advantage of LPG gas cylinder, which ladies find, is that very easy to control. Whenever they want, they can start, they can extinguish it, they can increase or decrease. But in wood or coal, or you cannot do such operations. So they are difficult to control. Though in stoves you can do this increase decrease, but starting and extinguishing is a slightly lengthy process, inconvenient and lengthy process. Is it all right? So it should produce large amount of heat. So producing large amount of heat is called high calorific value. I will explain to you now what is calorific value. It should not produce harmful gases. Like I told you, carbon monoxide, then other harmful gases that are produced normally are sulfur dioxide, nitrogen oxide. So it should not produce those gases. Even ash, after burning, like coal and wood, some amount of unburnt substances remain, they are called ash. So it should be minimum. Now it is very difficult to get a fuel which is having all such properties. So based upon our requirement, whatever are the major characteristics in which we are interested, we should select the fuel which is having that. Okay. Now I told you I will be explaining the calorific value. If I take 1 kg of petrol, 1 kg of cow dung or 1 kg of wood and burn, the amount of energy liberated would be different. So the amount of energy that is liberated by complete combustion of 1 kg of substance is called its calorific value. So combustion of 1 kg of fuel is its calorific. So unit would be, energy is joule. So I am telling kilojoule per kg. So I am telling calorific value unit is kilojoule per kg. So now for certain important substance every time, for cow dung it is 6000 to 8000 kilojoule per kg. For wood it is more than this, it is 17,022. Coal, it further increases 25 to 33. Then for petrol and everything all, you should remember it is around 45 to 50,000. And but for hydrogen it is maximum, which is 1.5 lakh. So maximum is 1.5 lakh for hydrogen and minimum is for cow dung 6,000 to 8,000. Here the band is quite more because it depends upon how dry it is. Similarly for wood. Okay, so this is about fuel. Now we'll go to study what are the harmful effects of burning fuel. If we are using the fuels which we have discussed, so what are the harmful effects? First, carbon fuels like wood, coal, petroleum, they release unburned carbon particles. Now these fine particles unburned of carbon, they are causing air pollution, and person breathing those air may get various respiratory disease. Most common is asthma. So that is why in villages ladies used to find that problem, because they used to burn wood, and from wood the smoke that used to come would carry good amount of carbon particles, and working day and night for a long period of time, so these carbon particles were causing asthma to them. Secondly, wood we are bringing from forest, so deforestation is taking place. Now if we are not using wood, so deforestation has got reduced from this. Then incomplete combustion sometimes will take place, and you will get carbon monoxide gas, which is poisonous gas. I have discussed about this to you, its effect. Okay, then combustion of the most of the fuel is giving carbon dioxide to the environment. As I explained to you, that carbon dioxide is causing global warming. So that global warming means the earth temperature is increasing. So this is resulting in melting of polar glaciers. Now melting of these polar glaciers will lead to rise in level of seas and oceans, and this will put low-lying areas underwater. So these are the harmful effects of using the fuel. One more effect is given, is that burning of coal and diesel gives a sulfur dioxide to atmosphere, which is a suffocating and corrosive gas, and burning a petrol engine gives nitrogen oxides, and all these oxides, when rain drops, get dissolved in it and form acid. So we say that it is an acid rain, and this acid rain is harmful for the crops, for the buildings, for soil, and in case it falls on you also, it may cause skin problems and various things. So these are the important harmful effects of burning fuels. So now what to do? So I have given the few solutions that we are undertaking. Now you see, now petrol and diesels are used in automobiles to a large extent. So we are replacing it with CNG, compressed natural gas. Now this gas produces very small amount of this harmful gases, or we say that their exhaust is clean. So it is a clean fuel. It is very small amount. So in this manner we are reducing. Other thing is, now also we are replacing the automobiles with electric vehicles. Now you will say, if we are using electric vehicles, then electricity would come from power stations. So in power stations, good amount of such fuels were being used. Now we are not making any new power station that will use these conventional fuels, and we are also decommissioning some of the power plants using conventional fuel and replacing them by new technology like nuclear power, wind power, solar power, which we call it clean power stations, so that there they will not cause any pollution. So these are important corrections that we are doing in this regard. Now a very small topic, I thought I will explain to you, that how does a matchstick burn. Now matchstick has got two parts, one is stick and other is the rubbing surface, which is on the sides of the box. Now match contains antimony trisulfide and potassium chlorate, whereas rubbing surface contains glass and red phosphorus. Glass is used so as to increase the friction so that heat energy should get released. Now with this heat energy, red phosphorus gets converted to yellow phosphorus. Initially, long time back, instead of red phosphorus they were using yellow phosphorus, but as I had discussed, the yellow phosphorus has got spontaneous combustion properties, so it is not safe to use yellow phosphorus, so we are using red phosphorus. Now by friction with powdered glass, heat will get liberated and this red phosphorus will get converted to yellow phosphorus, and in a similar manner it will react with potassium chlorate, oxygen will get liberated, and then with oxygen and this heat energy from yellow phosphorus, antimony trisulfide reaction will take place with oxygen and matchstick burns. Combustion take place of this antimony trisulfide and matchstick burns. So this completes this chapter. I hope you have understood. If you have liked my explanation, you can subscribe to the channel and like it and press the bell icon so that you will be notified when I post a new chapter. Thank you.